Hi, my name is Jason Arrigo. I'm an applications engineer supporting TI's power modules. Today I'm going to be demonstrating the EVM of the LM-ZM33603 power module. The small footprint and wide input voltage and output voltage of this device makes it ideal for almost any application, including 24-volt industrial and medical applications. So let's look at some of the features of this device. The LM-ZM33603 is our 3-amp device, and the LM-ZM33602 is our 2-amp device. They have a wide input voltage range of 4 volts to 36 volts, and the output voltage range is 1 volt to 18 volts for up to 2 amp for both devices, and up to 1 volt to 13.5 volts for the 3-amp device. The device is packaged in a 7mm by 9mm compact QFN package and can be synchronized to an external clock. The graph on the right shows our safe operating area, which is the thermal performance of the device. The graph shows that the device can be operated up to 105 degrees C and up to 3 amps of output current with graphs of 4 different airflows. So now I'm going to demonstrate the EVM and show the proper connections and the features of the device. So the device is going to be powered up using our input power supply and connected to a load. And then we are going to also show how to properly measure ripple using our oscilloscope. The LM-ZM33603 is located here on the board. The input power is connected to the input terminal block on the top, and the output load is connected to the output terminal block on the bottom. There's also test points for monitoring the input voltage and the output voltage. And these test points are only meant for connection to a digital voltmeter, because these test points aren't capable of handling higher currents when connected to the input supply or the load. There's also test sockets on the input and the output for measuring ripple and transient response. And there's headers for selecting the switching frequency and the output voltage. There's also test points on the right side of the board for measuring the features of the device. And there's also footprints for extra capacitors if needed in the application. So now I'm going to demonstrate the proper way to measure output voltage ripple on the EVM. So when measuring output voltage ripple, it's not recommended to use a scope with a long ground lead. This ground lead will pick up noise. The inductance of the ground lead will make the ripple measurement not look as good. So it's recommended to use a scope probe with a closely coupled ground spring. And so the socket of the EVM on the output is made for this type of ground lead. So as I insert this probe and ground lead into the socket, it makes a nice close connection to the board. Now I'm ready to measure ripple. So I'm going to turn on the power supply, and I'm going to turn on a 24-volt power supply. So now the device is powered up at 5-volt output. And then as I turn on the load, I'm going to turn on a 2.5 amp load. And so now the device is delivering 2.5 amps at 5 volts. And then as I change my time scale, I have the device, the scope is already set up for AC coupling, and I'm going to change my voltage scale down to 10 millivolts. So now we can see by measuring the ripple in this way, we're able to get a nice tight ripple, output voltage ripple measurement without any extra noise. So with that, you should be able to quickly and easily evaluate the LM-ZM33603 EVM. For more information, go to ti.com/power modules. Thanks for watching.